Okay, now we'll look at the potential divider. So the potential divider, what is potential? Well, that's your energy per charge, okay, so work per unit charge, which is voltage. Okay, so if I said something was 10 volts, then that would be some sort of potential. Remember, you measure potential at a point. You know, a voltmeter would measure two sides of an object, okay, and it's measuring the potential at that point. Let's say it's 10 volts, and the potential at that point, and let's say it was 5 volts, the voltmeter would read the potential difference, which is 5 volts. Okay, so we're looking for energy per charge. Now, the potential divider essentially grabs your 10 volts and will split it, okay? So that instead of having 10 volts, we could split it into 5 volts and 5 volts. And it does it with a simple circuit. This is the circuit that you see. It's just going to be two resistors. Okay, let's label this resistor R1, label that resistor R2. We have an EMF and we have an output voltage. Okay, now let's say we're looking at I'm just going to draw on here some ideas. So let's say this was 10 volts there and 0 volts when it comes back. All that wire there will be 10 volts and all that wire there will be 0 volts. Okay, so if you put like just a little detector there, it would say 0 volts, or a detector there, it will say 10 volts. Now we're ignoring the resistance in the wires. Now energy will be used going across the resistor. So on this resistor here, energy is going to be used per coulomb. Now that means when you measure here, then you're going to get a different potential from 10 or 0. It's going to be somewhere in between 10 and 0, because some energy will be lost across this resistor and then some more energy lost across this resistor. So the best thing is it actually splits in the ratio of the two resistors. If both these resistors were the same size, so let's say this one was 10 and that one was 10, then it was split 50-50. So in the middle, the potential measured would be 5 volts. And essentially, if you now attach something like a motor to that output, you would then get a 5 volt supply to a motor. Now, I've already said that the ratio of the two resistors will give you your output voltage. So how do we write that in a formula? Well, your output voltage will be equal to your EMF, let's say in this case 10, multiplied by the ratio of the resistors. And it's the ratio of the top line is the one that you're actually measuring across. Okay, so let's say we actually want to measure across this one. Let's say that one was your voltage output, then it would be R2 over R1 plus R2, okay, as your fraction. Now this example, easy, okay, post it, post your answer, okay, see if others agree with you, and maybe look at doing some others. You could just change these in your notes if you wish to have a harder one.